Welcome to very first lecture on database management system. Myself, Mr. Kumar, Assistant Professor, Department of ACE. So this is our subject name, starting with introduction part, and then we have different types of database management systems and overview of it. So today, on very first lecture, we'll discuss about, first of all, what is the necessity to learn this, what are the objectives we have, and what are the course outcome, why to learn this course, and then a brief history and introduction about it. That part we'll discuss today, right? And this is your third year first semester open elective course, and with a course code of 2250570, and we're studying it in third year first semester, right? And we have 3 credits for this course, and we also have a practical laboratory for this with the credits of 2, with a credit of 1. Yeah. So very first, what is a necessity, or what is the objective of this course? So if you learn this course, right, so we'll start with the basic concepts of the BMS, right? What is the necessity of it, what is the data, what is a database, and what is a database management. That part will start with this. And in the second chapter, we'll study about design of database entry using entry relationship models. We also call them as ER diagrams. And in the third chapter, we'll talk about relation models, concepts, which includes tables, keys, and integrity constraints. And we also study about normalization techniques to avoid redundancy and to improve the efficiency of the data. And in the fifth chapter, we talk about transactions flow, workflow, and how your concurrency controls and the recovery mechanisms will improve your data integrity. So these are the reasons why to study this course. Coming to the outcome. So why, after completion of this course, what knowledge or what information you are going to get, what outcome you are going to carry once you finish the course. So very first one, we are going to study, you will get a detailed knowledge of introduction of data, DBMS, and what are the relational and non-relational databases we have, and how to insert the data, how to retrieve the data, how to modify the data in various database management techniques. So we are also going to study SQL, and we also study NoSQL in this, and various control mechanisms for managing of data or retrieval of data, and to avoid redundancy in data and to improve the data efficiency while using or accessing this data. So this is a major outcome of this course, right? So to study. So coming to the syllabus, these are the 5 modules we have in our course time. Usually will take around 30 online sessions. If I go with the offline session, it consumes around 48 hours. And if you want to study in textbooks for this, you can go with a DBMS by Mr. Raghu Ramakrishnan. It's a TMH Publishers 3rd edition. And for the recent concepts, you can go with DBMS by Korth. It is also a TMH. And various reference books are also there. DBMS, its implementation, management, and design by Mr. Peter Robb. SQL, the complete reference by Mr. James Groff. And Oracle for professionals, it's a TMX production, and database systems using Oracle. So these are the various textbooks and reference books what we have to study in the due course, in this due course. Okay, right. So coming to the very first part, introduction. So first of all, what is the data? Right. So see, I'm handling a session called on DBMS, right? So my name is Mr. Rupa Kumar. So my name is also one of the data, right? And college name, student name, right? Subject name, marks, everything. So all this data, right? It's a data. Normally we'll call it as a collection of raw facts. So raw data or raw information collection, we call it as a data. So this data is of different forms. Right, it might be in the form of digital. Usually we'll use digital data only. So nowadays, so this digital data we are storing in different formats to manage it or to re-access whenever it is required. So this is about data. Clear? And these datas, right? By second, enormous of data, thousands of terabytes of data is generated per every second. So large number of database management tools and large number of databases storing this enormous data in day to day, right? So this is about what is DB data and what is database. So database means it's a collection or arrangement, right, or storing of this, right, interconnected data, interrelevant data, interrelated data. So example, student details if I take. So normally a student will have its name. So if I take a student name as Yashwant, so its name and his roll number, what is his address and its contact details and his age, his gender, his marks, and his attendance percentage, its backlogs, all this information belongs to particularly one student. This particular one student data normally will be called as a database. So even any universities, any website, any colleges or any education institutions, many will see some examples now. So all this, they will maintain a database, right, to store all these informations. So this is to, right, reuse the data whenever is needed, right? So that is about database. And what is the necessity of database management? So remember, database management, it's not is, right, it's not a data, it's not a data, it is a software, right? DBMS is a software. This software manages storing of data, accessing of data, or retrieving of the data. For example, there is a data. So this is your data or database. There we have a database here, and this is your database management, DBMS, and here the users, they are the various users. So these users, right, they want to access the data, but this access will not be granted directly from the database. So this database management system will monitor all this data, right? So for suppose I want the student details. So I want student details. I want mail ID credentials. I want purchase details. So all this information will be maintained by these databases, right? Student visa, how much marks he got in particular Python subject, how much marks he got in particular ADC subject. So marks of a student. So that information, of course, it will be stored in DBMS. It will be stored in database only. But retrieving and storing of data from this will be managed by this DBMS, right? And mail ID. So I want to use my Gmail password. So for this Gmail, right? So my username password will be stored in the Google's database. So that will be monitored by this DBMS. Okay. And when I'm opening various orders, such as, for suppose, if I open Amazon. So if I open Amazon, in the Amazon, if I open my orders, right, in the my orders button, it will show lot many previous history of my purchases. This all details with the prices and what is the cost of each product, on which day I was purchased and on what day it was delivered. All this data will be stored in the database, and that was organized by the DBMS. So simply I can say one simple straight point is, if there is no, right, DBMS, if there is no DBMS, right, there is no internet. I can straightly say that, because internet accessing itself needs some credentials. So if I want to use a Google, right, account or a Gmail account in the Google Chrome, right, I need my credentials. So when you open a Google Chrome, it asks you to go with right, guest, or it will go with some user, maybe with my name or maybe with other name. So what is the role, right? Admin. So it might be admin entry, or it might be a guest entry, or it might be a some already existed account entry. So this account information again stored in the database. So this database again monitored by the DBMS. So straightly I can clearly say, if there is no DBMS or there is no databases, there is no internet at all, no use at all, right? This is about what is a data and what is database and what is the DBMS, right? Let me give you a brief little history about this database management system. So long ago, olden days, how this data will be stored or monitored. So in the olden days, data was stored in the books and file systems. So if you observe in some olden days, so if I want to maintain a record of a student, we used to maintain a register like this. So it's a serial number, right, 1, and it's the name of the student, and class, and his roll number probably, and it's marks, right, etc. So serial number 1, 2, 3, 4, 5, and name is Mr. Ramesh, Mr. Laveen, Miss Panidhi. So like that, there are so many names, and Ramesh is studying 10th class, Laveen is studying 6th class, okay, and Panidhi is studying 7th class. So different the classes, roll number is 4, 3, 5, 8, 12. They are the roll numbers, and marks in particular subjects such as Telugu or Hindi or English. So if I take in English, marks are 48, 72, 86. So they are the different marks for different subjects. So this is a usual, right, book and file system which we used a longer days ago. Right. So the very simple difficulty in this is if I want to change the roll number of Mr. Ramesh, which I mentioned here. So what is the only possibility I have? I have to change this 12 and I have to mention it as some 44 because his roll number was changed. So the only possibility which I have in this is strike off and rewrite it. So that was the only right possibility we have. And updation of the data is not possible. Right. Addition is not possible in that. So we went to an advanced version of this. So we went to the other versions of this. So next we have file system. So file system means you already know, right? Many in our days, in our day-to-day life, you are using computers, right? And these computers have so many drives, right? D drive, E drive, or F drive, something. In E drive, again, we have subfolders, and subfolders we have again subfolders or directories. So in these directories, so this is Ramesh folder, this is college folder, right? In the D, we have directory, there is a college folder. So in the college folder, we have again first year, second year subfolders, and this is personal folder where we can store all our personal data such as certificates and achievements. So like that. So now the point is I want to retrieve a particular file, right, from this. So again, I need to keep on search in which place I stored. For suppose this is the college information. If I got a memo or any particular mark sheet, where this particular mark sheet I have stored, where I kept this mark sheet report. So there is a confusion in personal information or in the college, because college related means my first year data will be there, second year data, third year data will be there. In that my marks might be available, or I may stored in my personal credentials. So there is a lot of confusion or a lot of ambiguity while you are retrieving or recalling the data. And again, modifying also a little bit difficult to us. So some drawbacks we have, and other drawback we have here is security. So anybody can modify my own data. So there's a problem with security. There's a problem with redundancy. Redundancy means repeating of data. I may again and again restore or store the same copy of information multiple times, which wastes my data. Right, that is other problem. And we also have a problem with the data integrity. We have a problem with indexing of data also. These are the various problems with this flat file system. So nowadays computers we are using, right? So this flat file system having a couple of advantages, such as we can let me talk about advantages first. So we have advantages of backup. So I can take a backup, and whenever I reuse or I can change my system, I can use it. So, and one more drawback which I have here is addition or modification. Editing option is there. I can even access from other places. Remote access is possible. And I have a option of sharing and portability. So these are the other options. So these are the advantages with this flat file system. And we are also having some disadvantages, right? So the disadvantages includes, right? Yeah. First one is security, because anybody who knows my password of the system can modify my data, can change my data. That is a one drawback. And the second drawback we have is data retrieval. If data was lost or my drive was crashed, so that retrieval is also a big problem. Data retrieval is again a big problem. Third one is redundancy. Data redundancy means repetition of data. And the fourth drawback is data integrity, I mean rearranging of data. And the very fifth one is indexing of data. So data indexing. So this is the drawbacks which we have with this flat file system. So to overcome all this, right, we are moving to the, so the latest one which we are talking about it, right, that we are talking is database. So this database, right, is a solution of all these problems what we discussed as of now. So this database, right, having a couple of advantages which are disadvantages of flat file system. So advantages, retrieval of the data is very much easy with the database because we are storing data in different formats. So many different models of data storages we have. So based on the data storage models, we can retrieve the data. So that is one advantage. And security enhancement will be there because for database we have encryption algorithms, encryption methods. So these encryptions protects our data without, right, lose accessing. And the third one is redundancy, means if any data is duplicated, so it will verify and will give a caution to us the data was the repeated. And the next advantage is integrity. So arrangement of data will be in a well mannered, right, well mannered because of various methods we are adopting here. And the last one is indexing. So I can call the data. So I can call the data as, right, very comfortably because we are, right, giving a numbering system or indexing for each and every element or every object which is stored in the database. So these are the advantages what we have, right, with the database. So that's the reason this is a necessity of, right, studying or go through this subject, right. So this is about a brief history of the database, right. Now, what are the various models we have in this DBMS, right? So in the due course, we are going to study few among them, but different types or different models or different styles of data storage. Very first one is RDBMS, Relational Database Management System, where data is stored in the form of rows and columns. So data can be accessed in the form of rows and columns, especially. So example for this is Oracle. There are so many versions, very popular database management system tool, right? And MySQL is also one of the popular database management tool, and PostgreSQL. These are the examples of relational database management system, right? Coming to the NoSQL, not only SQL. The full form of this is not only SQL. DBMS means it is a non-structured, unstructured database management. Here in this, data was stored in the form of, right, key value pair, or in the form of documents, or in the form of tables, right? So in this, for suppose example for this is Venkat, right, is a name, right, called with 23 series 4, 23 series 401. It's a name, number of 23 series 401 is Mr. Venkat. So in the university portal, when you are searching a result, if I enter this total number 23 series something, right, like 23 7y 1a0 401 something, so what happened? So the total, a complete information of 401 will be displayed, like what is the result, how much marks he will got, whether he passed or failed in his subject, etc. So it means I am, right, accessing this information of Venkat, total data information of Venkat with a number. So with a number, so this is a key value. So value is the Venkat here, key is this number. So data will be stored in this format. So best example for this is MongoDB and Reddy. So these database management softwares are using, right, these comes under NoSQL DBMS. And the third one is a hierarchical database management system. So in this, data will be stored in the form of a tree. So I mean to say tree structure. So for suppose if you go to any university or if you go to any college, for suppose there is a vice chancellor here, right, then we have other people. So, right, and from there we have deans, and Dean academics, Dean exams, Dean R&D, etc. So these are the deans, and from there we have Dean academics also, Dean academics, and from there we have head of the departments, right? HOD, ECE, HOD triple E, HOD mechanical, HOD CSE, right? And then we have faculty here. So what happened is hierarchical order will be there. And remember, while you are accessing data, so certain permissions will be given or certain limitations will be given to access these informations, right? So the problem in this is this limitations with this limitation with this data is it's a hierarchy only, because a faculty cannot access data which is connected with the dean. But if I want to change a data, right, from of dean, it's not possible, right? So that might be its advantage in some cases, that might be a disadvantage in some cases. I'm just giving one raw example here. So this hierarchical structure, this implementation is quite complex, because maintaining this order and limitations is very complicated structure. So that was the problem in 1960, right? In 1960, IBM proposed, right, information management system, one software, but it's only for their own employees. An example for this, HDBMS I'm talking. And for NDBMS, it is network database management system. In the network database system, each node or each database device is act as a node, and they are connected in the form of graphs. They are connected in the form of graph, right? So best example, right, I'll show you here. There is a university here. So it's a branch, big size university. From there, it's a math department. It's a math represented in a graph. And this is a library. This is admin black. And remember, this admin black, right, connected with the math department, admin black connected with the library department, and library is connected with the math department, math is connected with the library department, and there is a, right, NSS department, or yeah, NSS department or a club. So then again, this math people also in connected with the NSS, and library people also connected with the NSS, and admin people also connected with NSS. So one and all, which are, right, which are connected interlinkly, one to all. So this type of structure generally represented comes under network database management system. In 1964, right, Codicil company, they designed their own network management system software for their employees in 1964. This is one of the best example for this NDBMS. And the last one is object-oriented database management system, which nowadays we are using. And example for this is Wasant Object Database and ZODB. So nowadays we are using this. And this data will be stored in the form of group of objects or branch of objects. So object-oriented database helps you to access content-wise or branch-wise or module-wise, so which reduces your efforts. So that is an advanced version of database management system which we are using nowadays. So this is about various database models what we have in current days. So coming to the right applications where we are using this DBMS. So very first one, we are using applications. We can see a wide range of applications in banking and financials to maintain all your credit and debit transactions, and normally to maintain your monthly statement, to generate your monthly statements, to generate your bills and all, and in finance to monitor or to store about holdings and sales, right? In coming to the universities, just we talk about to maintain about registration information and what is the grades or marks, etc., student data and all, and in the reservation systems, so to reserve the seats to whom the particular seat or accommodation, etc., will be allotted, and various schedules to maintain the schedules, and especially in communication, so keeping records of our calls, right? Call record, mean at what time to whom I called, and to generating our monthly bills, right? And in enterprise informations, especially in the form of sales, accounting, human resources, manufacturing, and other online outlets. So in many places, for wherever involvement of data will be there, we are using this DBMS, right? So coming to the necessity or need to study this DBMS. So very first one is, right, data redundancy and inconsistency, to avoid the data redundancy and inconsistency. And second one is where there is a difficulty in accessing of your data. So we need database management system. And isolation. So when you have multiple files and formats, right, separating them will be easy, right? But similar type of files with a different amount of data, I mean different sort of data with similar type of file, so isolation will be very much difficult. So to isolate them, right, we need database management system. And to arrange the data or to add the new constraints or to change the existing constraints, so data integrity issues will arise. So for that we need the DBMS. And atomicity of the updates. So normally for suppose I can explain you with example here. So when I'm doing a transaction, right, for suppose if I transferred 20,000 rupees, right, to a account, right, using various online payment method or your own method. So the point here is whatever might be the reason, this total amount may transfer or the total amount may not transfer. There is only two possibilities. One possibility is amount may be transferred if everything's gone success, or the amount may not transfer, right? It may be in your own account only, but there is no such chances that half of the amount is transferred, rest half in your account, or 70% is transferred. There is no such thing. So this comes under atomicity of update. So whether if you made any update, it has to be either 100% success or 0 success. There is no intermediate successes in this. So to maintain such atomicity of updates, we need database. And concurrent access anomalies. So means to avoid, right, on time, one time updating of the balance sheets or one time updating of credentials and all. If the same person or two different persons are having the same information, I mean to say same data is monitored by two different persons. So if the changes happened on same data by two persons, right, it affects on the data integrity, right? So that problem will be overcome by using DBMS. The last one is security problems. So to overcome the security problems also, we need the database management system. So this is about today's session. So tomorrow we'll talk about, right, what is different views of data and what is the necessity of abstractions of data and other things. Thank you. We'll see you in the next session.